All right. Booting Linux off of Google Drive. All right. Competitive is a vice of mine. When I heard that a friend got Linux to boot off of NFS, yeah, there's a lot of people that do this actually. Well, maybe not NFS, but like PXE boot. You can boot Linux off of the network. I had to one up her. I had to prove that I could create something harder, something better, faster, stronger. Like all good products, this began with an idea. My mind reached out and grabbed wispy tendrils from the aether, forcing the disparate concepts to coalesce. The mass gained weight in my hand, and a dark, swirling color promising doom to those who gazed into it for long. Yeah, that's anyone using this in production. That this will promise doom. But anyway, on the brink of insanity, my tattered mind unable to comprehend the twisted interplay of millennia of arcane programmer time and the ragged screech of madness, I reached into the mass and steeled myself to ground lest I be pulled in and found my magnum opus, booting Linux off of a Google Drive root. It does sound like a D&D opening, doesn't it? I like this article already. But how? I've wanted this to remain self-contained so that I couldn't have a second machine act as a helper. My mind went immediately to Fuse. Ooh, yeah, I don't know if Fuse is going to work because you've already got to be booted, I think, to use Fuse. A program that acts as a file system driver in user space with cooperation from the kernel. Fuse, it was actually, interestingly enough, used to make something that stored data. This was my most fun thing I saw done with Fuse. Someone stored data in the latency of network cables, like in pings, essentially. So in the caches of the NIC, the routers, and everything on the internet, they were storing data in that, and they were just pinging it back and forth, and they could actually store data that way. It was really cool. I don't think you can boot a Linux kernel off of that, though. I don't think there's enough space. But yeah, a program that acts as a file system driver in user space with cooperation from the kernel. I had to get Fuse programs installed in the Linux kernel initram fs and continue networking. How bad could it be? The Linux booting process. The Linux booting process is, technically speaking, very funny. Allow me to pretend I understand for a moment. Well, you'll understand more than I have. I know there's BIOS, and I know that passes off to a kernel, and I know the kernel loads some stuff and tells devices what to do, and then you get a prompt. Those are the four stages. So we'll see how I do. The firmware BIOS UEFI starts up and loads a bootloader. Got that. Bootloader loads a kernel. Got that. Kernel unpacks a temporary file system into RAM, which has the tools to mount the real file system. Huh. That's interesting. The kernel mounts up a real file system and switches the process to the init system running on the new file system. Interesting. Do live disks just stay in that temporary file system then? But that must be what init ramfs is. I see this all over Linux. I've always wondered what it was. So now I know. It's exactly what it sounds like. A proof of concept. The init ramfs needs to have both network support as well as proper Fuse binaries. Thankfully, DryCup makes it easy enough to build a custom RAM init fs. So you could use Fuse inside init RAM FS and then effectively do whatever you want, boot off of whatever you want. That's kind of crazy. That's kind of cool. I decided to build this on top of Arch Linux because it's relatively late. Arch, by the way. No, I don't use Arch anymore, but he's using Arch, by the way, because it's relatively lightweight and I'm familiar with how it works, as opposed to something like Alpine. Git clone, Dracut, Podman run. Okay, so we run a Docker container. In the container, I installed some packages, including the Linux package, because I need a functioning kernel, compiled Dracut from source, and wrote a simple module script in modules fuse module setup.sh. I require binaries fuse, fuser mount, use IO, return 1, so that check, depend, install. Okay, that makes sense. That's it. That's all the code I had to write. Buoyed by my newfound confidence, I powered ahead and building the EFI image. Okay, and then we booted in QEMU. Fatal, no or empty root argument. Refusing to continue. You might want to save this to a USB stick after mounting them and attach it to a bug report. Dropping into debug shell. Okay. Hacker voice, I'm in. Now to enable the networking and mount a test root. I have already extracted an Arch Linux root into an S3 bucket running locally. So this should be pretty easy. Okay. Interesting. This should be pretty easy, right? I have to manually set up networking routes and load the drivers. IP link. So you got to enable DHCP. Oh, so this is how to do the S3 bucket. Use path, fuse, sysroot, switch root. Okay, so that's the command. So you essentially chroot every time you boot Linux. You chroot out of the init ramfs. Interesting. Honestly, I didn't know what I expected. Seems like everything is just gone. Alas, not even a tab completion can save me. At this point, I was stuck. I had no idea what to do. I spent days just looking around, poking at the switcheroo source code. All for naught, until I remembered a link Anthony had sent me. How to shrink root file system without booting a live CD. In there was a command called pivot root that switch root seemed to call internally. Let's try that out. Log out, sysroot. Failed to change root from dot to old root. Invalid argument. Oh, there's a kernel panic. Not syncing, attempt to kill init. Apparently pivot root is not allowed to pivot roots if the root is being switched is in the ramfs. Unfortunate. So how are you supposed to do it then? How are you supposed to get out of init ramfs then? The Stack Exchange answers tell me to use switch root, which doesn't work either. However, part of that answer sticks out to me. Init ramfs is rootfs. You can neither pivot root nor unmount it. Instead, delete everything out of the rootfs to free up the space. Find xdev exec rm. Overmount rootfs with new root. Wow. Attach standard in and standard error to the new dev console. Oh, wow. So basically just swap out all the files, like copy all the files out of, or delete everything in an random fs, like the initial root system, and then paste in your own. Yikes. Would it be possible to manually switch to root without specialized system call? What if I just chroot? Explicit user argument required to run it as user manager. Oh, I need to run the chroot command as PID1 so system can start it properly. I can actually tweak the init ramfs init script and just put up my startup commands in there and replace switch root call with exec chroot sbin init. Okay. I put this in the init sh, strict cut, source code, rules, bypass root variables, checked later, loaded the module, set up the network, tried to mount everything. I also added exec chroot sysroot init, and instead of the switch root command, rebuilding UFI image and Arch Linux login. I sit there in front of my computer staring. It can't have been that easy, can it? Surely this is a profane act, and the spirit of Dennis Ritchie ought to have stopped me, right? Nobody stopped me, so I kept going. I log in with the very secure root password of root as root and unceremoniously drops me into a shell. Okay. At last, Linux booted off an S3 bucket. I was compared to stare at my achievement with others. All I needed was a fresh program to include in the screenshot. Fast fetch. Failed to receive from these. Seem like DNS isn't working, and I'm missing dig and other debugging tools. Wait a minute. My root file system is on S3. I can just mount it somewhere else with functional networking to root in and install all my utilities. Wow. Okay, this is wild. Some debugging later, it seems like systemd resolved D doesn't want to run because it failed to connect standard out in the journal socket, ignoring permission denied. I'm not about to try to debug systemd because it's too complicated and I'm lazy, so instead I'll just use Cloudflares. Cloudflares? Oh, they're DNS. Yeah, that makes sense. Fast fetch. Okay. Okay. Virtual machine. Bash. Memory. Where's the disk? 0 byte of 3.98 gigabytes. Fuse S3FS. That's awesome. Okay. I look around, making sure nobody tried to stop me. My windows are intact. My security system had not tripped, and the various canaries I had set up around the house had not been touched. I was safe to continue. I was ready to have it run on Google Drive. Google gets involved. There's a project already that does Google Drive over Fuse for me already. Google Drive OCaml fused. OCaml mentioned. Thankfully, I have a Google account lying around that I hadn't touched in years ready to go. I followed instructions, accepted the terms of service that I didn't read, that I'm sure this violates, creating all the OAuth 2 secrets, enabled the APIs, installed Google Drive OCaml Fuse from AUR into my Arch Linux VM, patched some PKG builds. It's been a while, and lo and behold, I have mounted Google Drive. Mounting Google Drive and a very long rsync runs later, I have Arch Linux on Google Drive. Just kidding, it's never that easy. Here's the non-exhaustive list of problems I ran into. Symlinks don't work. Yeah, that makes sense. Hard links don't work. It is so slow. Yeah, every single disk operation has to run out to Google Drive. Relative symlinks don't work at all. No dangling symlinks. Important for the stuff that links to proc and isn't mounted, or stuff that just hasn't been copied over yet. Symlinks outside of Google Drive don't work. Permissions don't work. Neither do attributes. Did I mention it's slow? Yeah, there's no metadata attached to the files. With how many problems there are with symlinks, I have half a mind to change the Fuse driver code just to create a file that ends in .internal symlink to fix all that. Google Drive completely compatibility be damned, but I have challenged myself to do this without modifying anything important. No kernel tweaking, no Fuse driver tweaking. Aw, you could at least do that. But so I'll just have to live with it and manually create the symlinks that rsync fails to make with a hacky sed command in the rsync error logs. In the meantime, I added a token files generated by my laptop into initramfs, as well as the Google Drive Fuse binary and SSL certificates, and tweaked a few settings to make my life slightly easier. Okay. Yeah, and now Fuse root bin boot dev etc home. It's nice to see that timestamps kind of work, at least. Now that all that's left is to wait for the agonizingly slow boot. Chroot, sbin init file not found. Uh-oh. Perhaps they did not bother to stop me because they knew I would fail. I know the file exists since, well, it exists. So why is it not found? Simple. Linux is kind of weird, and if the binary you call depends on a library that's not found, you get file not found. Well, that makes sense. Sort of. It doesn't make sense in the error, but it makes sense conceptually. So we link in the binary. However, these symlinks don't actually exist. Remember how earlier we noted relative symlinks don't work? Well, that's come back to bite me. The kernel's looking for files in sysroot inside sysroot. Luckily, this is an easy enough fix. We just need to have sysroot linked to sysroot without links. So we mounted? What? Okay. Now time to boot. It took 5 minutes for Arch to rebuild the dynamic linker cache, another minute per system unit, and then nothing. The startup halted in its tracks, timed out, waiting for device. Oh, interesting. Dependency failed for serial on TTYS0. Guess I'll have to increase the timeout and reboot. Yep. Luckily I did not take infinite time to boot. That's what I would have that's what I would have been afraid of. Got to an Arch Linux login. So I'm so close to victory I can taste it. I just have to increase another timeout. I set login timeout to 0 in Etsy login defs in Google Drive and tried logging in again. This is highly convenient, by the way. You go edit your config files in Google Drive. Sysroot. Okay, wait. Sysroot. Quite the naming scheme here. Sounds like a programmer. The system work, but naming is the hard part. Yeah, right? Exactly. Thankfully, there is a cache, so subsequent file reads aren't nearly as slow. Okay. But yeah, here's the fast fetch fuse Google Drive OCaml fuse. Booted off of Google Drive. Here I am, laurel crown perched upon my head, my chimera of Linux and Google Drive lurching around. It's really slow, but it works. But I'm not satisfied yet. Nobody had stopped me. Are they going to run Doom on it? Nobody had stopped me because they want me to succeed. I have to take this further. I need to take this to work on real hardware. Oh, not just a VM. Okay. Fortunately for me, I rented servers and now have an extra laptop with no storage just lying around. A wonderful victim for my test. There are a few changes I need to make. Use the right Ethernet driver and not the default E1000. Do not use a serial display. Change the network settings to match my house's network topology. I need the R8169 driver for my Ethernet port, and let's throw in Powerline into the mix because it's not going to impact the performance in any way that matters, and I don't have an Ethernet cord that can reach my room. I built the unified EFI file, and now I throw it on the boot, and I'll stick it in my old server. Despite my best attempts, I couldn't figure out what the mod probe directive is for the laptop's built-in keyboard, so I just used mod probe HID USB and used an external keyboard to set up networking. All right, and then after all that, fast fetch. It's on an Inspiron 5547 old Haswell chip. Fuse Google Drive OCaml fuse. Nice. This was my magnum opus, my great work. This is the mark I will leave on this planet long after I am gone. The cloud native computer. Nice thing is, I can grab the screenshot from Google Drive and put it here. Whoa. Cloud native computer be upon ye. Or let's try that again. Whoa, cloud native computer be upon me. Despite how silly this project is, there are a few less silly uses I can think of, like booting Linux off of SSH, or perhaps booting Linux off of a Git repository and tracking every change in Git using GitFS. That could be cool. That could be really cool. Possibilities are endless, despite the mindless, middling usefulness. If there's anything I know about such technology, it's that moving everything to the cloud is the current trend. As such, I'm prepared to commercialize this for any company wishing to leave their unreliable hardware storage behind and move entirely to the cloud. Please request a quote. Oh, that didn't. Oh, it was supposed to take me to a contact page. It just took you to the home. That's funny. Please request a quote if you're interested in true cloud native computing. Unfortunately, I don't know what to do next with this. Maybe I should install Nix. Oh, that's awesome. No, you should install NeoVim next. That'd be best. NeoVim running from Google Drive. You can edit your files, your Google Drive files, while booting off of Google Drive. This is This is the way. This is the way. In fact, boot your Linux distro off of Google Drive so you can install EOVim and use it to edit your Google Drive files. This seems legit, right? Right? That seems reasonable, right? Right? Seems reasonable to me. This is awesome. This sounds like a really fun like weekend or couple weekend project. I like stuff like this. This is insane. 10-minute boot time. You know what? If you put it, I wonder how bad the boot time would be if you put it in like Google Cloud. If you put it a little closer to Google Drive, maybe the boot time would be like a minute or something. I don't know. I think it might be interesting to see. But in reality, this sort of thing gets used all the time in the data center. Like they move storage off into a separate box and then have compute in a different box, and they communicate over like network hardware. Like this happens a lot. So this isn't that crazy. Doing it at a kernel level rather than like a one level lower in the hypervisor is where this is interesting, and the fact that it's just Google Drive. So, but this is quite awesome. I like it. I like the article. So hey, if you like this article or if you hate it, if you think it's dumb, let me know in the comments below. Like and subscribe to the channel. If you like this and want to be a part of recording these, it usually happens every Monday around 8 p.m. Pacific time over on Twitch. All right, have a good one.